This lesson is about evaluating limits that are indeterminate. So direct substitution is not always possible, and sometimes when you do direct substitution you might get an answer that is 0 over 0. Be easy to think that's undefined, but in mathematics 0 divided by 0 is actually indeterminate, meaning we don't know. It might be defined or undefined. 0 divided by 0 is different than any other number in the numerator. So in that situation, usually there is something algebraically we could do. We could also have some calculus tools we'll learn later on, such as L'Hopital's rule. But right now, with algebra tools, how can we evaluate the limit? So step 1, if I evaluate at 3, both the numerator and denominator would be 0. So this is a good indicator to know that likely we can factor and remove a discontinuity. So in the denominator, if I factor it, the two numbers are -3 and +5. We can remove the discontinuity that allows 3 to give us 0. So then what we're left with is 1 in the numerator and then 3 for x. That gives us the answer 1/8. Look at number 2. Again, -1 and -1 gives us 0 over 0, which is indeterminate. So it's a good indicator to know I can factor. So the numerator, the two numbers are -8 and +1. That allows me to remove the discontinuity, and then what I'm left with, -1 subtract 8, and I get the answer -9. Here, first, don't assume, but 2 in the numerator and denominator give you 0. So we're going to factor. That's, what is that, -2 minus 3. This is +2 and -2, difference of squares. So x subtract 2 is removable. Now I can plug in 2, and I get -1 over 4. Number 3. I did number 3. Number 4. Again, if I use -4 in the numerator and denominator, it is indeterminate. I'm going to factor the numerator by grouping. So the first two, x squared, factor out in x plus 4. The next, factor out in -1, that's also x plus 4. The denominator, factor out in 2x, that's x plus 4. We're getting there. So we have x plus 4. I have x squared subtract 1. Well, that's a difference of squares, so I can write that right away, factored. And now that it's completely factored, I can remove the discontinuity that's causing me issues. Now you can plug in -4. So that's -3 and -5. I think that's 15. And this is -8. So I get 15 over -8. Number 5. Again, 6 gives me an indeterminate situation, so I'm going to factor. Don't forget to write the limit notation and then factor. So this is, what is that, -12. Is that right? No, -6 and 4. The denominator on the side, we can go 3 times 12, that's 36, and -20. The two numbers then would be, what would it be? It would be 18 and 2. That's what it would be. So -18 and -2. Do a substitution with -18 and -2. And then group these. So 3x, x subtract 6, -2, x subtract 6. So then you get the two factors you need. Now I can remove x subtract 6. That's a removable discontinuity. Plug in 6 and I get 10. 18 take away 2. You could reduce it down if you like. And it's 5 over 8. Number 6. This is called sum of cubes. Now when I plug in -2 and -2, it is indeterminate. Sometimes it's hard to remember a sum of cubes. One way we can understand it is the cube root of 8 is 2. So -2 is a 0. So if I divide -2 into this, this is what's left over using synthetic division. So in the numerator, as a factor, it would be x plus 2, and then I'd have 1x squared minus 2x plus 4. The denominator, the two numbers are 10 and 2. Then you can remove the discontinuity there. So now I have a negative 2 I can plug in. So negative 2 would be 4 plus 4 plus 4, right? 12. And then 8. So what is that? 4 over 6. No, divide by 4. 3 over 2. Got it. All right, next page. Here's another way to remove a discontinuity is to rationalize. And so we're going to use what's called the conjugate to do that. Now, first, again, make sure 4 makes it indeterminate, which it does. 0 over 0. Here. So the conjugate is the opposite connecting sign. So root x subtract 2, root x plus 2 is like a difference of squares. The numerator, root x times root x is x, and negative 2 times 2 is negative 4. The middle terms would cross out. The denominator, I'm not going to multiply out because it already crosses out. So I'm not going to multiply out. Just put them beside each other. Notice that x subtract 4 removes. So now the discontinuity is removed. When I plug 4 in here, the square root of 4 is 2 plus 2, and you get the answer 1/4. Number 8, 9 is, if you simplify it, is indeterminate. So I'm going to use the conjugate. That's root 4x plus 6. In the numerator, I'm just going to put them beside each other. In the denominator, it's just first times first, which is 4x, and then last times last, which is negative 36. Plug 9 in. Well, actually, I can factor out a 4 here. And I get the x minus 9. So now you can see it removed. Plug 9 in. 4 times 9 is 36. The square root of 36 is 6. 6 plus 6 is 12. 4 in the denominator. So the answer is 3. Number 9. Again, it's indeterminate. The conjugate is root x plus 1 plus 1. That algebraically will allow us to eliminate the discontinuity so I can evaluate the limit. The numerator, I'm just going to put them beside each other. The denominator, root x plus 1 times root x plus 1. Negative 1 times 1. So what you're left with is 1 take away 1, that's 0. So the x's eliminate. So now 0 is no longer a discontinuity. Now plug 0 in for x. The square root of 1 is 1. 1 plus 1 is 2, and 2 times negative 3, and you get the answer negative 6. Number 10, again, evaluate at negative 2, and you have 0 over 0, which is indeterminate. We're going to use the conjugate, so find where the square root is, change it to plus 4, top and bottom. Recognize the numerator, we'll just put it beside each other, so x plus 2 and root 14 subtract x plus 4. Just put them there. The denominator, just first times first, that's 14 minus x. Last times last, that's minus 16. When I look at the denominator, combine like terms, you get negative 2 minus x, or negative x minus 2. These are opposite factors, so that leaves you with a negative 1. And now you can plug negative 2 in. So a negative times a negative is positive 2. So it's 14 plus 2, that's the square root of 16, that's 4. Plus 21 is 25, and then it's negative. so it's negative 25. All right, or what did I do there? Let's try it again. Oh, that's not a 21. That's a 4. My writing. So again, this was the square root of 16, which is 4 plus 4, which is 8. And that makes a negative 1, makes it a negative 8. 2 more left. Let's do this. First, evaluate at 7. 2 plus 7 is 9. Square root of 9 is 3. So it's 3 take away 3, 7 take away 7. It's indeterminate. We're going to multiply by the conjugate, top and bottom. We're going to write the limit as x approaches 7. The numerator, 3 times 3 is 9. And root 2x times root 2x is just 2x, 2 plus x. That minus sign belongs to both. The denominator is x minus 7 and 3 plus the square root of 2 plus x. 9 take away 2 is 7 plus x, right? 7, that belongs to both. Let me write it out. So 9 take away 2 is 7, and then the minus with the x is that. These are opposite factors, but it still removes. So these are opposite factors. Now you can reevaluate at 7. 2 plus 7, that's 9, and the square root of 9 is 3. So 3 plus 3, and that gives me negative 1 over 6. One more. Let's do this. So evaluate at negative 3. Negative 6 plus 5 is 9, and the square root of 9 is 3. Take away 3 is 0. Negative 3 plus 3 is 0. It's indeterminate. The conjugate is the square root of 2x plus 15. Subtract x, top and bottom. We're going to write this again, the limit as x approaches negative 3. First times first is just remove the square root sign. X times negative x is negative x squared. The denominator, I'm going to leave it just like this. This one has one more hook to it. If I look at the numerator, I can factor that now. So first of all, to factor it, I want my x squared, my power term, to be positive. So I'm going to factor out a negative out of each one so I can factor it. And then I can factor further. So the two numbers that multiply to negative 15 and add to negative 5 are negative 5 and positive 3. That's where the discontinuity will be removed. So x plus 3 is removed. Now I can evaluate at negative 3. So negative 3 take away 5 is negative 8, but the negative makes it a positive 8. Here, 2 times negative 3 plus 15, that's the square root of 9. So it's 3 subtract negative 3. So that's 6. So that's 4/3. Done, right? All right, that was your lesson on evaluating limits that are indeterminate. Mr. G Math over and out. Proud of you. Till next time.